So let's download SFML. So I'm gonna go to the download section, and the latest version currently is 2.5.1. Select that. Now there's a bunch of options so you can get SFML to run on Windows, Mac, or Linux. You can see there are two sections. There's the 32-bit section, and there's the 64-bit section. I'm gonna explain what the difference is, but before that, you might notice also there's Visual Studio C++ 2013, 2015, and 2017. So those libraries are compiled with that version of C++, or that version of Visual Studio, right? So for us, we're gonna pick the 2017 version at the very top. But now the choice is, should we do 32-bit or 64-bit? And what's the difference? Well, for computers, you have two options. Whenever you want to run a piece of software, you either run a 32-bit software or a 64-bit software. Now, what's the difference? Well, a 32-bit software will run on both a 32 and 64-bit OS operating system. So fundamentally, 32-bit and 64 stands for basically your CPU. So this is your CPU here. And whether or not, and this is your memory, this is your RAM, right? It fundamentally stands for how much memory can your CPU address or use, right? So when you're communicating between those two things, so this is RAM or memory, right? Both of these guys are communicating with each other. On a 64-bit machine, let's start with a 32-bit machine. On a 32-bit machine, you can only do 3.8 GB of RAM. You can only use 3.2 GB. So this is for 32-bit. For 32-bit, with a 32-bit CPU, right, you can only address, or you can only use up to a maximum of 3.8 GB RAM. For a 64-bit, let's put 64-bit here. I drew in the wrong section, so let's do 64. Right? Delete that. For a 64-bit, you have your CPU over here. That's communicating with your memory or RAM. For that, you can basically go to the 2 to the power of 64. Here you go to 2 to the power of 32. So if I grab my calculator here, and I check what's 2 to the power of 32. So 2 to the power of 32, I get 4.2 billion, right? Which is around, so that's 4,294,967,296 bytes. So this is how many bytes you can address. And if you don't know what bytes are and megabytes and all that, we'll talk about all of that later, right? I'll have a session, a lecture to explain all these are. But essentially, what that means, you can only have 3.6 GB of RAM in your computer. And so if I go to my task manager here, give it an hour or two. So in here from memory, You can see for memory I have 64 GB of RAM. Because I am running on a 64-bit computer with a 64-bit operating system. So I can use that much RAM. If I was using 32-bit, I can only go up to 4.2 billion bytes, or 3.8 GB, around 3.8 GB, right? So that's basically what 32-bit means. It means how much memory can your CPU work with? And you have a limit of 3.8 GB. So what about 64? Well, 64 is 2 to the power of 64, which is this number. It's huge. It's massive. I think that's 18 petabytes. That's a lot of memory, basically. So that means I can use a whole lot of memory, right? And this is a 64-bit CPU. CPU, 64-bit. So here's the thing, though. You could have a 64-bit CPU and run a 32-bit OS. So if your operating system is 32-bit, which means it's a 32-bit version of the operating system, it can run on a 64-bit CPU. However, you are limited with 3.8 GB of RAM. If your operating system, if Windows is 32, then you can only run 3.8. Even though your CPU is 64, you can only run at 3.8. So that's why with a 64-bit CPU, you want to run 64-bit OS, which means you have access to a whole lot of RAM. So for a 32-bit CPU, you cannot install a 64-bit OS on a 32-bit CPU. You cannot install a 32-bit OS. You cannot run. Sorry, let me repeat that. You cannot run a 64-bit OS on a 32-bit CPU. You cannot run a 64-bit OS. You cannot run a 64-bit application. You're limited to 32. If your CPU can only do 32, then you can only do 32. However, if your CPU can do 64, then you can do 32, and even 16 and 8. So you might have heard of 16-bit. Ooh, that's tiny. So you might have heard of 16-bit, and there's 8-bit, and there's 32-bit, and there's 64-bit, right? So these are either applications or operating system applications or CPUs, right? So back in the day, Windows only supported 16-bit, right? It could only use 16-bit because at the time you only had the 16-bit CPU. 16-bit CPU, right? But then we upgraded to 64-bit CPUs, and now we're running at 64-bit CPUs, right? So that's essentially what it means. It means 32 can only address this much RAM. 64 can address a lot more RAM. 18. You saw that huge number. I don't know what that number is. Just big. It's massive, right? So that's the difference. And you can also, so a 64-bit CPU can run 64-bit applications. It can run 32-bit applications. It can run 16-bit applications. It can run 8-bit applications, right? So whatever your CPU is, that's the ceiling. That's the limit. It can support things under it. So 32 can support 32, 16, and 8. 64 can support 64, 32, 16, and 8. But a 32 CPU cannot support a 64-bit application and higher, right? So this is the ceiling. This is the limit over here. So that's what that means. So for all of us, if you bought a machine anytime after 2006, you have a 64-bit CPU. right? But there's no guarantee that you have a 64-bit operating system. You could be running on an older operating system. That's possible, but it's very, very, very rare. It's probably everyone is running at 64-bit, and 99.99999% you're running at 64-bit operating system with a 64-bit CPU. How can you verify that? Well, if you go to your file explorer, go to this PC, right click, go to properties, right? You will see here that in here it says system type 64-bit operating system on x86 based processor, right? Cool. Now here's the thing though. Our application currently is set to 32-bit mode. This is x86. x86 is 32-bit, x64 is 64-bit, right? So we have the option to create a 32-bit application, which can run on a 64-bit CPU and operating system. But why would we? 32-bit is dying. So we're gonna switch here, the type of application we're gonna create, we're gonna switch it to 64-bit, right? So we're gonna use a 64-bit CPU, 64-bit application, which would run on a 64-bit CPU and a 64-bit operating system. We're not going to support 32-bit because it's too old and no one uses it anyways. Right? So that means our library here that we're going to grab is the 64-bit version, right? Now, one thing for the naming, it might be a little bit confusing. You've seen x86 and there's x64, right? x86 is actually the architecture of the CPUs we're using today, or that Intel has set in like 1980s. So the family of CPUs, the way the CPU is designed and architected, the way the CPU works, the way it's designed, and the design is called x86. So x86 family of CPUs. x86 is the CPU that runs on your PC and your Windows machine, on the Xbox, the new Xbox, the brand new Xbox, what is it? Xbox was after the Xbox 360. So I think Xbox One. Xbox One and above is x86. PS4 and above is x86, right? That's the family of CPU. Don't confuse it with 32-bit and 64, right? And I want to clear that up. This is the name of the family of CPUs, right? The type of CPU. It's an x86 family of CPUs, which run on PC, Xbox One, and 64. Now, Apple Macs used to run Intel CPUs, right? It used to run Intel. Now they don't run Intel. So Mac 2019, any Mac under 2019 ran Intel x86, but the new Macs from 2020 and above, now Macs uses another family of CPUs. That family is called ARM. ARM is the family of CPUs that is on your phone. So the type of processor, the name of the type of processor that you use on your phone is called ARM. Now the Mac, the M1 Mac M1 runs ARM, right? What else runs ARM? Phone, Android, and iOS, they run ARM. Your tablets run ARM. Some desktop computer and servers, they run ARM. Not computers, really servers. Some servers run ARM. The Pi, there's a small tiny computer called Pi that runs ARM, right? So there's multiple types of CPUs, right? So these are the ARM family of CPUs. And this is the family of ARM CPUs. Okay, and then here's the family of, whoops, the family of x86, right? Intel and AMD, they are an x86 family of CPUs, right? And then you have PowerPC. PowerPC. That was, I think, designed by IBM. So if you ran a PS3, PlayStation 3, if you ran an Xbox 360 or Xbox, the first Xbox, the original Xbox, right? These used PowerPC CPUs, right? It's a different architecture. So whenever you write your code, you have to compile your code to run on these type of CPUs. You have to compile your code to run on these type of CPUs. You have to compile your code to run on these type of CPUs, right? If you compile your code for PowerPC, it will not work for x86. It will not work for ARM, right? So whenever you have your code, it has to be compiled for the target CPU. Now we're only going to use x86 family of CPUs, right? That's the only thing we're going to worry about. But that's kind of an introduction for you to tell you the different types of family of CPUs out there. Right? They're designed differently, and they have different families, right? And those designs have names like PowerPC, x86, or ARM. Now, why am I talking about this? Well, it's good information. 1, 2, x86. When you saw it here in Visual Studio, right, you saw x86 and x64. For whatever dumbass reason, x86 sometimes refers to 32-bit of CPUs, right? 32-bit CPU for the x86 family, right? Oops, that's the wrong family. The x86 family here. x86 family sometimes is referred to 32-bit CPUs, sometimes referred to x86. For 64, it's x86 underscore 64, which is 64-bit. Or sometimes you might just see 64, just 64. You would see x64. x64 or x86 underscore 64, those are the same thing. They refer to the x86 family that supports 64-bit. x86 alone refers to 32-bit for whatever reason. But I want you to understand that x86 is the name of the family of CPUs we are supporting, right? And it can also mean the type, the how many bits the CPU support, which is 32-bit. Now, for ARM, you will never see ARM x86, right? That like 32-bit, right? This is just this stupid naming convention only for x86, right? For ARM, you'll see ARM. I think it's called ARM 7 and ARM. So normal ARM is 32, and you have ARM 7 is 64-bit, right? So this x86 is just for the family of CPUs, right? So in Visual Studio, this x86, it means we're going to compile for x86, the family of CPUs, and 32-bit. This x64 means we're going to compile for the x86 family of CPUs with 64-bit. So that just to make that clear, right? So we're just going to do 64-bit for x86 family of CPUs. And we're going to download the 64-bit version of this library. Make sure you're downloading the correct version of the library. Not version, the correct version, the correct architecture, which is 64-bit. Right? And here it says, on Windows, choosing 32-bit or 64 libraries should be based on which platform you want to compile for, not which OS you have. Indeed, you can perfectly compile and run 32-bit on 64, like I mentioned, right? You can run 32-bit software on 64-bit operating system, right? Because Windows has backward compatibility, right? So that's there. So But for us, we're just going to target 64. That's all we're going to do. We don't care about 32. 32 is really old. You shouldn't be using 32 or compiling for 32 or creating 32-bit applications in 2020. Or for that matter, like anytime after 2015, 32-bit should have been dead, but for whatever reason, that's still around, right? So we're only going to support 64. So let's download that. We're going to download 64 for Visual Studio 2017. Even though we have Visual Studio 2019, it's fine. Shouldn't be an issue. So 2017 is fine. Right. Cool. So we got that covered. We got that working. Let it download. It's going to take a minute or two. So, how are you guys? How you doing? Talking to myself. Da, 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 da. Fun. Any day now. Any second now. There you go. Thank you. All right. So we're gonna extract this. Extract to SFML, right? If you don't know what this application is, it's called WinRar. Just in case, for whatever reason, you don't know what it is. WinRar. You can go to www.rarlab.com and download and install the latest WinRar version. Not the beta version, the release version. Do English. Where's English here? English and 64. Don't do 32-bit, 64. There you go. But anyways, so this is SFML right here. And the only thing we need, so there's the documentation folder, right? Which we're going to delete. There's these two folders, README files, which we're going to delete. Example files, we're going to delete. Bin folders, we don't need any of this. We would need this if we would compile or if we're linking the library dynamically. We're not doing dynamically, we're only doing statically, so we don't need this bin folder. Delete that. And these are the two only folders we need. We need the include files and we need lib. Right? Now, if you look at this lib, right? In here we have static libraries and dynamic libraries. Okay, so what I'm going to do, it's really important whenever you're doing this, you're going to the documentation and reading the documentation. So I'm going to go to learn, go to tutorial section, and then we're going to do SFML in Visual Studio. Right? And there's this section here that talks about dynamic and static libraries. So here, libraries must add to the project linker dependencies that you, okay, that's, yeah, I understand that. In here, this is the part. The settings down here will, the settings shown here will result in your application being linked to dynamic version of SFML, the one that needs the DLL files. We're not doing dynamic. Oh, here, important. It's important. It is important to link the libraries that match the configuration. So SFML, whatever, -d is for debug, and for release has no -d. We'll talk about release and debug in a second. Okay. Showing blah, blah, blah. Okay. If you want to get rid of the DLL, have SFML directly integrated into your executable, you must link the library statically. Static libraries have the /s suffix. So /s/d, that's for debug and static. Right? So that's important. So I'm going to delete anything that doesn't say /s. Right? So SFML audio.lib, delete. SFML audio.lib/d, delete. SFML audio/d, delete. SFML audio/s, we're gonna keep /s or -s, dash or slash, whatever. This is static because there's an s there. There's an s, that's static. Static, we can delete SFML graphics. We can delete SFML graphics/d. This is the debug version of DLL. This is debug version. /s is static, /s static, /s static. So there's /s release and /s/d for debug. We'll talk about release and debug later on. SFML main, delete. SFML main /d, delete. /s we're keeping. Hold on. I don't think there is a SFML main debug. Main. I mean, static main. Do we need static main? Do we need main? Hold on, Control Z. So I'm gonna keep SFML main. Oh no, this is never mind. Yeah, I'm gonna keep this main. I don't know because there's no main /s. I don't see main /s, so that might be. I don't know. I'll keep this for a second. Networking. Let's see. Networking. There's networking /s, so I can delete this. Delete this. /d. Delete this. So we just need SFL networking /s. Networking /s/d. System. There's a /s system, so delete this. Delete this. Delete this. So SFML/s we're keeping. /s/d we're keeping. /s/d we're keeping. Window. We're gonna delete the window. We're gonna window /d delete. /d delete. /s we're keeping. /s/d we're keeping. /s/d we're keeping. And we can keep these, right? So basically, I've deleted anything that doesn't have /s, except SFML main. I don't know what SFML main is. No idea, but we're keeping it. CMake, we don't need CMake. We can delete this folder, right? And there, we've cleaned up the project a little bit, right? We deleted all the things we don't need. All right. So these are all libraries. This is a library, right? Now, there's this file. It's called dot. It says program. You can see here, if I hover over it, it says program debug database, which is PDB, right? We'll talk about that in a second. But my library is the .lib, right? PDB is for debugging. I'll talk about debugging in a second. All right. Going back to this stuff, let me zoom in here. Let's talk about debug and release. What is debug? What is release? So we have debug and we have release. 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 I think that's how you spell release. Let me double check. Yeah, there we go. I'm not a complete idiot. All right, cool. What is debug? Debug means that your program is not running at 100% speed, right? It's not running at its full speed because there are debug information. Debug information are basically information that helps you figure out what's wrong with your application. If it crashes, if it's not running well, a debug information or a debug application will allow you to figure out what's wrong with it. A release application runs at 100%. This does not run at 100%. This does run at 100%. Right? So it's super fast. However, if it crashes, it's much harder to figure out why it crashed. Right? Whenever you're giving your application to if you're releasing the game, you want to release it in release mode to run at 100%, right? Because the difference between debug and release can be massive in speed. So this game might run at like 10 FPS. And in here, it could run at like 80 FPS or 80 frames per second. So the difference is huge. It's much, much harder to figure out what's wrong with the game if it crashes in release. And it's much easier to figure out what happens here if it crashes in debug. because you can just debug it and figure it out, right? So that's the difference between debug and release. We're gonna work with debug, and when we release our game, we release our game. That's why there are two versions of these libraries, right? There's /s, only /s. So if you look here, for audio, there's only /s. Only /s means it's static, but release. /s/d means it's static, but for debug, right? It's not the fastest library, but we can figure out what's wrong if something crashes. And so this file that says pdb contains debug information. It contains some information that allows to and help us to debug. And this is the unoptimized code. So the unoptimized code that runs not that fast is over here in /s/d. And this file contains things that help us debug the application. Let's just put it that way. In like future episodes, I'll just go in a lot more in detail. I'll just show you, right? So here's the code, and here are just things that help us debug it and figure out what's wrong with it, right? So when we're linking this library, when we're adding it to our project, we're gonna add it in both debug and release mode, right? So we're gonna do debug and release. So that's there. So that's what he's saying over here, right? And in the documentation, you can see we need to include all these files in our application. So that's there. All right. So let's get started, right? So the two things that I need this include folder and the library folder, both of these folders. So I'm gonna right click, copy both of these guys, go to Visual Studio, right? You see here main.cpp. You can right click on main.cpp and say open containing folder, which should open my containing folder, right? I'm gonna go one step back. So I was here, I'm gonna go one step back. And what I'm gonna do is I'm gonna create a new folder called dependencies. Dependencies, all capital, and probably spelled wrong. Dependencies. So I will create a folder called dependencies. I'm gonna paste both of these guys here. Hold on, before I paste them, I need to make a SFML folder. So I'm gonna say SFML. I'm gonna add both of these inside just to indicate that this is the SFML dependencies. Let me spell check this. And if you know what, I spelled this correctly. Holy shit! If you don't know what dependencies are, they're just the things we need for our application to run correctly, right? In our case, it's our library. All right, so let's link this library in our application. How do we do that? First of all, let me delete the class here. One thing I forgot to mention is that as an exercise, if you want to train on this a little bit more, I would like you to create a class that's called player, and it contains all the player stats. And another class is called enemy, that contains all the enemy stats, and print these things on the screen. Right, print those stats on the screen. So the class would contain like damage, HP, attack speed, movement speed, magic damage, physical damage, mana, stamina, things like that. Bunch of variables that has information on the player and the enemy. Create objects for the enemy and the player, and then print the variables on the screen. Assign their values and print them on the screen. That's as an exercise that I was supposed to mention, but I forgot. But here we are, so I'm mentioning it now. All right. So let me delete everything. All right, so I want to link SFML here, right? So what I'm gonna do is right click on RPG game, go to properties, right? RPG game is our project, so we want to link SFML into our project. Now it's very important, extremely important. You see this section here? It says C/C++, right? Was it this section? or VS. One of these. I think it's either C/C++ or VS directories. No, it was definitely C/C++. Okay, so the thing that I'm highlighting here, C/C++, this will not exist, or it will not show up if you don't have a main.cpp file. If you don't have at least one source file, and we call this as a source file, if you don't have at least one source file, this section will not be there. And I can show you if I right click and delete this, click on delete, and go to properties, you'll see that it disappeared. There's no C/C++. So make sure you have one source file, right? At least one source file too. So we make this work. So I'm gonna make my main code again. So include my stream. Main turn 0. Cool, which is cool. All right, so that's my code there. And so I'm gonna right click on my project, go to properties, and now we need to link to our application. Now, make sure when we're doing this, for the configuration, we will start with debug. So we're gonna start with the debug configuration. For the platform, we're gonna select x64. Right? So make sure we select both of these. So in here, in VS directories, there's two sections, include and library, or include directories and library directories. Now, I didn't explain what includes are. Includes are just a bunch of source files with the .hpp extension, right? I'll explain what .hpp is later on. For now, we need those source files, right? So the code is split between the library and the .hpp files. So we need both of these. I'll explain these in a lot more detail later on. All right, so here when it asks for the include directory, we need to specify it. So if you highlight include directory and click here, you can see there's like an arrow here. Click on it, click on edit, make the window a little bit bigger, right? Now, in here, we need to set the path of where my project is, or where my include files are. And my include files, if we go here, you can see that my include files are in here. So this is my directory, C, user, conta, source, repo, RPG game, dependencies, SFML include. So if I copy this, and I double click here, paste it, this is where my include library or my include files are, right? So this is the directory. Now, here's the thing. This is an extremely bad practice, all right? The reason this is a bad practice is because this is the path to my include files, and this is the path for my computer. It's in C, users, conta, source, repo, RPG game, dependencies, SFML include. Now, if you give this project to your friend, right? Your friend might put the entire project in the D drive. So now your project is not in C, users, conta, repo, source, repo, RPG game, dependency, SFML include, right? It's in D, right? And this is the path. It's RPG game / dependency / SFML / include. So you can see those two paths are completely different. And so that means that if I give this project to my friend and he tries to run it, it will try to look for the library. Visual Studio will try to look for the library in this path. And since it can't find it in this path because your project now is completely different in a different place, it will give you an error, which is a problem. So how can I make this dynamic? How can I say, if I give this project to my friend, wherever he puts the project, it will always point to dependencies SFML include. How do I do that? Well, luckily, in Visual Studio, there are things that are called macros. And if you've never heard about macros, macros are essentially shortcuts that point you to a specific direction. You can have macros on your keyboard. So you can, for example, if you press the Control C is a macro for copy. Control V is a macro for paste. You can set your own macros on your keyboard. It's very similar here. So you can see here there's a button that's called macros. If I click on it, right, you will see that there are a bunch of keywords that starts with the dollar sign. So all of these are starting with the dollar sign, and two open and close bracket and a name inside it. And so basically, these macro have the value written next to them right here. So for example, if I look for a specific macro called project dir, dir. Project dir stands for the project directory, and you can see there's a dollar sign project dir, which the value is C user conta source repo RPG game, right? Which is extremely similar to this here. Why are there two RPG games here? Why are there two RPG game? Okay. Oh, RPG game. This is here. RPG game. Okay. Right? So that's the project directory. Right? Project directory is not going to work for us because the path will take us in this folder, RPG game. So RPG game is this. But we want to go RPG game dependencies, right? So that macro will not work for us. But essentially a macro is that if I put the macro here, if I add it here, if I double click like this, you can see the macro is added. And this macro is basically this path. So when Visual Studio sees this macro, let me delete all of this, right? Notice here, I want you to look here, right? If I say X, and press enter, you can see X over here, okay? If I double click on this macro, right? This macro is now added. So you can see that projector will take me to C users, conta, source, repo, RPG game, which is this location. C user, so let's compare these. C user, conta, source, repo, RPG game. So this is the location it takes me. If I move my project to the D drive, Visual Studio will figure out that it was moved to the D drive. So this macro is dynamic. Wherever my project is, it will get that path for me, rather than hard coding it, rather than typing the path myself, which is very, very bad. Okay, so now there's another macro for solution there, and you can see this is the macro that we want. So solution there takes me to, let's compare these two, C user conta source repo RPG game, which is where we are here. I want to be in here. So I'm going to use this macro, solution dir. So I'm going to delete this, right? And then I'm going to double click on solution dir, and it will add it to me. It'll add it for me. And so if you look here, it was added. It's the same directory that I want. Here. C users, conta, source, repo, RPG game. Okay, but that's not the entire path. I'm not in SFML. How do I go to SFML? How do I go to dependencies? Well, the rest is to me, right? This first part is dynamic. So if I move my project to somewhere else, it will be there, right? The other part is static. I can hard code it, type it myself, because I know if he moves this project, dependencies will always be there. SFML will always be there. Include will always be there, right? So I'm going to copy this part, dependencies /SFML/include. and I'm going to paste it in here, right? So now this says solution dir dependencies slash SFML slash SFML slash include, sorry. And if you compare these now, right? Let's compare this now. This says say C users, conta, source, repo, RPG game, dependency, SFML, include, right? While using the solution dir macro, okay? Which is super cool. Now, I would like to prove to you that this works, right? So what I'm gonna do, I'm gonna put two file directories. I'm gonna keep the macro over here, and under it, I'm gonna click on add, or above it, sure. I'm gonna have both of them, the old one and the new one. Don't do that on your end. I just want to show you the difference, right? So now if we look here, both of these are identical, right? They point to the same location. So if I press OK, I'm gonna close my project. I'm gonna save it. And I'm gonna move this RPG game. I'm gonna do cut. I'm gonna move it to my D drive. Paste it here. Right. So here's my RPG game. If I open my Solution Explorer, you will see that the macro was dynamically changed, but the old one was not, which would have caused a problem if we kept it. So if I go to Properties, Visual Studio C++, if I go here, look at this. Now, our macro, look at our macro. Our macro is now in D, RPG game, dependencies as file include. This is our macro. And the old one was in C, user, conta, source, repo, RPG, dependency as file include. This location doesn't exist anymore. If I try to put it in here, in the title and press enter, I'm gonna get an error from Windows. Windows cannot find this file, right? Because it's not there. I moved it to my D drive. So never hard code this. However, this exists. So if I copy this part, right, and I paste it in here, it'll take me to that location. And so the macro is dynamically changed depending on where the project is being taken. And there's a lot of different multiple macros. There's a macro for like the Clang analysis toolpath. There's a macro for app data. There's a bunch of macros for a bunch of things, and they're very useful. Macros dynamically change depending on the project, which is super useful, right? So I hope that cleared that up. So now I'm just going to remove this hard-coded line. I'm just going to do solution dir, dependencies, SFML include, right? So press OK. So we done the include. I'm going to copy this line because we're going to need it. I'm going to copy this line, right? Now I want to set, so I've set my include directory. Now I need to set my library directory. If I click here, I'm going to paste the same line, but I'm going to change a few things. The library location is SFML lib. So SFML lib, not SFML include. That's all I have to do. So I need to change the include, remove the include, and just add lib. So this is the location of my library. And it's a valid path. You can see D RPG game dependency as from lib. D RPG game dependency as from lib. That's a valid path. So press OK, click on apply, and there. This was set up for debug x64. Now that I remember, this has to be also for release. So you know what? What I'm gonna do, just copy this line, paste it here in a notepad, copy this line, the library one, paste it also in notepad, right? And just delete this line. I'm just gonna delete it. Delete, press OK. Delete, so delete this. Okay, so I've deleted them from both because now I want to do them for both debug and release. I can do debug and release in one selection. So if I select all configuration, it will do debug and release. So in here, I'm gonna delete different options. I'm gonna just delete all these, both these. I'm gonna make them empty, right? I'm gonna open this. Make sure inherit from parent or object defaults is included. Make sure that's included. This is for the include. Copy this, put it in the include. Right? Go to library. Make sure inherit from parent or object defaults is ticked. Paste that. Right? And now this is for both configuration. Click on apply. So now if I go to release, it's there. If I go to debug, it's there. Right? I set it for both configuration. I don't need to set it for all platforms because I'm not supporting Win32. I'm only supporting x64-bit. Right. So that's the only part I need for all configuration. Actually, I still need all configuration. I need to do it for the next section. So for C, C++, I want to go to the preprocessor. Go to the preprocessor definition, edit, right? Make sure you're doing inherit from parent or object default always. Press enter. Don't delete this. When it says different options, don't delete it. Just press enter and go down. And according to the documentation in SFML, you'll see that one of the things that says is that in this case, you will need to define SFML static macro in the preprocessor option of your project. So we need to add this macro, right, in our project, like this. Now, we already talked about what a macro is, right? Macro is a shortcut for something. And the preprocessor, we talked about also the preprocessor, it supports macros. So the preprocessor just replaces words with other words. And the preprocessor is the hash here, hash include, right? So this is a macro which is basically says SFML static. It says, hey, use SFML, the static version of SFML. So when we type this into the preprocessor definition, it will turn on some code inside SFML that will make the library run as a static library. Right? So that's important. So this macro just turns on a section of the code in SFML to make it link as a static library. So once we do that and make sure it's in all configuration, make sure it's all in configuration, press apply, right? And we're only going to do it for 64-bit all configuration, right? So now we're done with C and C++. Next, we want to go to the linker. So we've basically configured the compiler right now. Now we need to configure the linker. Remember when we said the linker needs to link your code with other people's code? Well, in this case, other people's code is SFML's code. So we need to tell the linker where to find that code to link it. So we need to go to linker, input, and this section. In this section, both debug and release are going to be different. So make sure we're going to do debug first. So debug x64, make sure those are selected. Go here, the additional dependencies, open it. Now we're going to type our dependencies. Now, this is going to be a lot of work. So essentially, SFML is saying we need to include all of these dependencies for this code to work. So what I'm going to do, okay, I'm just going to copy everything here. I'm going to copy all of this and paste it in here. Right? So let's see. We need, and my job is now to find the duplicate words. So I'm going to highlight graphics. So /s, this is static. We're going to link it statically. Graphics is here once. Windows here twice. So I'm going to remove window. System is here multiple times. So we're just going to remove any duplicates. This is a duplicate. This is a duplicate. This is a duplicate. So system only exists one. OpenGL32 exists twice. So remove it. Free type only once. This exists twice. So I'm going to remove it. This exists once. Once. All right, so all of these only exist once. which is great. So these are all the things that I need to make SFML work. To organize this a bit more, I'm gonna put everything that starts with SFML at the top. So SFML networking, I'm gonna put it here. SFML audio, put it in here, right? So now I've kind of organized SFML stuff at the top and everything down. Now, /s is for static. But right now, if you look at the configuration, we're in the debug configuration. So I need /s. So if I remember correctly, let me double check. /s/d. So /s/d 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 /s/d. This is only for SFML, right? And only for SFML. So I'm now going to copy off this and paste it in here. So these are the libraries we are going to use in our project. /s for static, /s for d, and that's what we're going to use for debug, right? So press OK, click apply, and now we're going to switch to release. Release is going to be the same exact thing, except we remove the /d. There's no /d, only /s. Because D stands for debug. And debug, and now we're in release, we're not in debug. So only /s, paste it, press OK, click apply, and there you go. That's done. Cool. That's it. That's all we have to do to link SFML, to tell the linker that SFML works. So, few things. So let's go from the very beginning as a review. Make sure you set all configuration, and then make sure you have include and library directories set. Make sure you're using a macro, and make sure inherit from parent or project default is set here. Once that is done, you jump into C/C+, and you go to the preprocessor. The preprocessor, make sure you're in all configuration, and you set, for whatever reason, all configuration is not done. So static. Oh, okay, that's weird. Whatever. So for debug, you can. Whoa, no. So I'm just gonna cancel here. I've done something wrong. So for debug, you can see here, SFML static exist. For release mode, you can see SFML static exist. So you just need all you have to do is just do all configuration and go edit and paste it there. All right, so that's the second part. Now the linker, you go to input. For linker, debug and release are different. For debug, we add all these libraries with /s/d. Now you realize there's a bunch of space here, so make sure there's no space. Move any space in here. Okay. So for debug, make sure it's /s/d. For release, make sure it's only /s. Right? Just gonna double check there are no spaces here. I don't think they do any harm, but remove them anyways. Why are they there? They might cause harm, I don't know. We'll see. So press OK, click apply. There you go. And now SFML should be linked to our project. Alright, how can we test that and make sure? Well, really easily. If I go to the SFML documentation, go to learn, go to tutorial, and go to same section where SFML in Visual Studio. So same section. At the very bottom, there's this code. Right, so just copy all this code, paste it in here, and run it. And if you see a circle, like hopefully I'm seeing right here, yeah, that means it's working. It's working perfectly. And you've linked SFML correctly. Now, linking for the first time will be very daunting. Whenever you're linking a new library, it's going to be daunting, it's going to be exhausting, it's going to be frustrating, you're going to have a bunch of errors, and you're going to hate your life. It's the same for everyone. Linking in C++ is tough and exhausting. So if you have any errors, go through the video again and make sure everything is set correctly. Make sure that you're on debug, make sure you're on x64. You right click on properties. Make sure you set on all configuration and go to V C++. You're setting include a library correctly. Make sure you're using a macro. Make sure the path is correct, right? And then you go to preprocessor. Make sure you're still on all configuration, and make sure that SFML static exists for both debug and release. Make sure you're on platform x64 again. This is also important. And for the linker in input, make sure your release x64 says SFML graphics /s or SFML Windows /s, all the SFML stuff /s. For debug, which is /s/d for x64. Win32, there shouldn't be anything there. We're not doing Win32 at all, only x64. Make sure all these are correct. Make sure, this is the directory setup, dependencies, SFML. You have your lib folder, include folder, all these, and everything should be linked correctly. So now if I switch to release, right, on 64 and release, it should be fine without issues, right? However, if I do switch to x86, we're gonna have a bunch of errors. If I press play, I'm gonna have compiler errors that says, hey, I don't know what the hell this is, because we never configured this for x68, which is 32-bit, because we're not using 32-bit ever. So make sure this is set in 64, and we're gonna keep it in debug. And you should see a circle. Cool. All right, hope that helped. Hope that made sense. And I think we'll stop here for now. And next time, we'll start actually writing the code. So this is code just temporary, just to make sure everything runs. Shouldn't be there. So next time, we're gonna explain SFML and start with SFML stuff. Exciting, finally. See you guys around, and have a good week.